Hello friends, welcome to Joy of Life. So today I'm going to do a problem that I have done before on this channel. That was my first problem in YouTube actually, and I was not very comfortable using the pen back then, and the handwriting was not acceptable. I feel I was checking the videos and I felt that I should remake couple of videos that I have done previously, and so I thought with the very first one, that is the problem number 41 that we did on this channel, which is a hard problem. The problem is first missing positive. So given an unsorted array of integer nums, find the smallest missing positive integer. So we'll be given with a array. So here are a few examples. You have been given with a 1 to 0 array. So the first positive number is 1, right? And we have 2 as well. So the first missing number that we don't have in this array is a 3. And rest all numbers which is less than or equal to 0, we can just ignore them. So similarly over here, I can see that I have a 1. I don't have a 2. I have a 3. I have a 4. I have a -1. So first missing positive integer, so anything greater than or equal to 1. So the number that I see missing is a 2. So 2 is our answer over here. Similarly, for the third problem, what we see is we don't have a 1. We have 7, 8, 9, 11, and 12. So 1, 2, 3, everything is missing. So 1 will be our answer in this case. So we are going to head over to the board in order to understand this problem in much more details, and do give it a try yourself. If you have seen the video previously, do let me know that if I was able to improve from that video or not. So I have taken an input over here. The number that I have taken in the array is 4, 3, 2, 1, 1, 2, and 6. So these are individual numbers. So if I put this first, let's understand how it will be if I sort this. So what will happen is if I sort this, I'll end up having something like this, right? And then what I can probably do is so first thing that we are doing is a sort, and then we are doing a linear scan and checking that what I have. I have a 1, I have a 2, I have a 3, I have a 4. I don't have a 5. So 5 would be my answer over here, right? So that is one of the naive solution that you can think of. So what will happen in this case is you are sorting the array, and then you are doing a linear scan as well. So you'll have a complexity like n log n for this, right? But we wanted to do better than that. So if even if you see there is a follow-up, that could you implement an algorithm that runs in order of n time and uses constant extra space. So that means we when they are asking us to do order of n, what they mean is that we go over the array only once. We can go more than once, but it should not be a nested one. So when you are doing a sorting over here, so the sorting algorithm, you cannot have a order of n complexity in a sorting algorithm, right? At the complexity that you have so many sorting algorithms with you, right? And nowhere you can achieve a order of n, right? The best we can get is n log n, but what we intend to do it is within order of n. So we will see how we are going to leverage what we have, and we are going to solve it. Okay, so before we jump into the solution, what I'm going to show you is something pretty interesting. So uh, consider an array like this, wherein we have just 1, 2, 3, and 3, 4, and 5, right? So this is pretty much sorted. So what will be your answer over here? The first missing is the number 6, right? So now if you see, this is one ideal case wherein we have 5 elements and we have all of the positive numbers starting from 1, 1, 2, 3, 4, and 5. Okay, now let's create an array and try to understand their relation. So what I have done is I have given the indexes of the array. So these are nothing but the index of the array. So you can see the array index are 0, 1, 2, 3, 4, right? For an array of size 5. And if I have to put this number inside this, what will happen? I'll be putting 1, 2, 3, 4, and 5, right? So now just uh, these are the values and these are the index. Just try to see the relation between the index and the value. So the value is always is equals to index plus 1. Why we are doing an index plus 1? Because we are interested from 1 and above. We are not concerned about 0 or numbers that's below it, right? So just now going by the example that we have taken 4, 3, 1, 2, 6. So if my array contains something like 4, 3, 1, 2, 6, and these are my indexes, say 0, 1, 2, 3, and 4. So let's say this is my array, okay? So we are now looking into the actual algorithm, how we are going to implement it. Just notice one thing over here. The number that we are interested is between 1 to the length of the array, because those are the number that we can fit in. So we can probably, given this array, we can fit in only 1, 2, 3, 4, and 5. So 1 will go to index 0, 2 will go to index 1. So we are talking about this relationship over here that we have established. 2 will go to index 2, 4 will go to index 3, 5 will go to index 4. So these are the index. So our target is to get this element back to their corresponding indexes. So what are we going to check? So we are going to go over the entire array once. So let me put down the algorithm over here. So we are going to iterate the array. And what are we going to check now? So let's say we'll take the example that we have been using all this while. So 4, 3, 1, 2, 6. So let's say this is my actual array. These are the values, not the indexes. So when I get a value, so when I start, what will happen is I will get the value 4 initially, right? So this is my first element. So first thing that I need to check is, does it fit between, if val between, so val is nothing but the value over here that I am referring to. Okay, these are the values of the array. So if val between 1 to length of array, then only we are going to consider it, length of array. So let's say length of array. Then only we are going to consider it. So in this case, what is the range, the fixed range that we have built up is between 1 to 5. So 4 is between 1 to 5, right? 4 falls in between 1 to 5. So what are we going to do is we are going to take 4 and put it in its right index. So what is 4's right index? So as per the relation, we know value equals to index plus 1. So if I do this, it will become index equals to value minus 1, right? If I have to just move this to the other side. So 4's correct index is 3, right? Where it belongs. That's what we see over here. Okay, so what are we going to do? We are going to swap whatever is there in the third index. So this is my third index, right? So we are going to perform a swap between these two values. We are just going to move these two values around. So let me create this array over here. I'll just make it a little short, and yeah, I hope it's readable. So let's put the array. So let's put it into its initial condition. Let's use this space over here. So this is my initial condition of the array, 4, 3, 1, 2, 6, right? So what are we going to do now? We are over here at this moment, and we need to swap between 4 and the 2. So we are going to swap. So we are going to swap the elements between I is pointed by this index over here, which is, I am putting the index over here with blue. Okay, and this is my actual array. So we are going to perform a swap between them. So we are going to put 2 here, 4 here, right? We just did a swap between them, and the rest of the elements remain in its place. So you see this, after this cycle, this value 4, which was initially at the 0th position, has come and sitting at its right position, right? So since we have done a swap over here, what we are going to do, we are just going to continue. We are not going to increment I. Remember, we are not going to increment I because a new value has came in this position. So here I was 0, and so I will continue to remain at 0 only because we have got a new value at that index now. So where 2 should ideally go? 2 should ideally go in value minus 1. So 2 should ideally go at the index 1. So 3 will come over here. 2 will go at its place. So see how we have moved 2 to its right position. So since we have performed a swap, we are not going to increment I again because we got a new value. Until we get a value that belongs there, we are not going to swap. Okay. So now what we are going to do, we are going to swap 3. So 3's right place is the second index, right? So we are going to put 3 there. So you can see now how one has came to a position, a right position. So we got a new value at I again. We are going to check again, but this time I see that okay, one is sitting in its perfect position. So what I'm going to do, I'm not going to do anything. I will remain. I will keep the array as is. So we'll not be touching the array. So I moves on to 1. This is the value, right? So 2 should be at the index 1. 2 is at index 1. So we are not going to touch it. I moves to 2. That means we are checking this value. Here also we are checking that everything is in its place. So we are not going to do anything. So I moves to 3, which means here. And again, we are not going to do anything. And I moves to 4. And this time what we see is the value at index 4 is out of range. So we are not going to do anything. What is the complexity over here? We have just iterated one time over the entire array, right? We have not done multiple iteration over it. Every element is sitting in its corresponding place according to this array, right? So in the 0th index we have 1, in the first index we have 2, in the third index we have 3, second index we have 3, on the third index we have 4, and on the fourth index we have 6. So now if I start a linear scan, so the first missing number that I will see is a 5, and 5 will be my answer, right? We are going to take the second example from Leetcode and we'll see how it fits our algorithm. So we have 3, 4, minus 1 and 1. So what will happen is here my interested range is between 1 to 4. We are concerned about any values that falls between 1 to 4. We are not going to consider any other values. So when I equals to 0, so what will I equals to 0 means the element we are talking about is this. So this guy should go into 3 minus 1 as per this formula over here. Its rightful index is 3 minus 1, so 2. So what will happen is we will be doing a swap. So minus 1 will come over here, 3 will come over here, and rest two values will remain unchanged. So we have a 4, we have a 1, right? So since we have made a swap, so we are going to continue ahead with I equals to 0 one more time. This value is out of range, so we are not going to do anything. We'll keep the array as is and we are going to go ahead. So I moves on to I moves to 1 now. Since we have not performed a swap, we are going to go ahead, and the interested element is this. So this element should go to the third index, right? So we are making a swap between this first index and the third index. So what will happen? 1 will come here, 4 will go here, and the remaining items will remain as is over here. Okay. And now we continue. Since we performed a swap, we are going to do a I equals to 1 again. And what we see that we get a value 1 over here. It is eligible for a swap. So it will swap with the 1 minus 1, that is 0th index. So 1 will come over here, minus 1 will come over here, and then 3 and 4 will remain at its place. So what happens is now I remains at 1 only. And this time I see that minus 1, 1 is the index number, so we have a value minus 1, and which is not falling in the range that we have, right? So we are not going to do anything, and we are just going to go ahead. Since we didn't perform the swap, I moves on to 2. We are talking about this element now. So 3, and 3 should be at the second index, right? And it is already in the second index, so we are not going to perform any swap. And now I increments to 3, means we are talking about this value over here, and 4 should be at the third index, and we see that it is sitting in its right place. Moves to 4, and which is out of bound to break the loop and come out. So when we come out of the loop, what we have is a 1, minus 1, 3 and 4. And as per the indexing system, this is the 0th index, this is 1, this is 2, this is 3. You see that all the elements that are in the range is perfectly sitting at their right index. So when I start rolling over this array one more time, what I get it, 0 has the value 1, which is fine. 1 has a value of minus 1, which it should be having is a 2. So I know that 2 is for sure a number that is missing over here. So we are going to say that the first missing positive is the number 2. Okay, and since we have talked about a condition over here, I just wanted to add a few things over here. So what we did is we check the boundary. We need to do some additional check as well. So some of the edge cases that I wanted to mention over here. Okay, so what if I have the array like this 1 1 1, or say 2 2 2. So when I get a 2, I should be replacing this with this position, right? And it has also the same number. So that check needs to be added. Check before swapping. Check values before swapping. If we are performing this swap, basically what will happen is it will go in an infinite loop. So 2 will be swapped with 2. We are not incrementing I because we performed a swap. So we are swapping again, 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 and again. So this is one preventive check that you need to add over here. And there is one more check that you need to add is, so this is just this check that we have over here, right? We have talked about, because we don't want to redundantly go ahead and do a swapping, right? So if value is equals to index plus 1, then we can simply ignore this and go move ahead, right? So we don't need to perform the swap in that case. So yeah, this is the entire algorithm all about, and we will see on the code that how it looks. So we are going to head over to Leetcode, and we are going to write down the code for the same, and we'll see how it all fits in. Okay, so over to the Leetcode, and what I am going to do is I am going to create a variable. So while so this I is the marker which index it is pointing to. So I will should be less than nums.length. Okay, so what are we going to do over here? We are going to first have to get the value that we are talking about. So we are talking about nums.I, right, over here. So, and this value should go to this index, right? So this, let this be my index. So IDX is basically pointing where this value should go, nums.I should go, because this is the formula that we have established over here. Index is equals to value minus 1. So value is nothing but your nums.I minus 1. So now this ith index value should be sitting at the IDX index, right? And what we are going to check, so we are going to have a preventive check over here before we perform the swap. So the first check that I need is nums.I, that is this number at all eligible. And what is our eligibility criteria? The number should be between 1 and the length of the array. So num_I should be greater than 0, and nums, right? Nums_I should be less than or equals to nums.length. So just keep in mind that it will be less than equal to, because we are talking about a one based indexed over here. So if there are four elements, we will be considering 1 2 3 4 and not 0 1 2 3, right? So this is my first eligibility criteria over here. And the next check that I we need to do is that num_psi not equals to I plus 1. So let's say num_psi is 2, right? And our I is at 1. So this means the number is already sitting in its right place where we don't need to perform a redundant swap. So I plus 1. So we will fall back to this formula at the moment. Val equals to index plus 1. This preventive check that we have talked about here, that the item is already sitting in its right place and we don't need to perform a swap. So this is that same check. So let me just make it easy for you. So this is my first check. This is my second check, that item already sitting in its right place or not. Then we don't need to perform a swap. And another check that we talked about, that is a edge case wherein we have duplicate numbers. So the number that I am going to swap with is already the same number, right? So in that case also performing a swap does not make sense. So maybe 2 is sitting on its right place. So you have incremented, you have found another 2. Now you're trying to place the 2 here, but there is already one 2 sitting there. So we don't need to perform a swap in that case. So in that case, what I can say, that num_psi, okay, should not be equals to nums idx. Okay, so what is the idx? Idx is that new index where it should go, right? This is the index. This is the index where the item should ideally go and sit. So if num_psi is not equal to the value at nums at index, means those two values are different. So first I have checked that is the number falling in the range, and then I'm checking is the number already sitting in its right place. And one more check that we are doing is prevent duplicate element swapping to avoid infinite loop. Why infinite loop? Because we are not going to increment I when we enter this block of code, right? We are not going to do a increment of I because we are getting a new value at the ith index. Because inside what we'll be doing is we'll be performing a swap inside this loop. Okay, so the swapping logic is very simple. We are going to use a temp, and what are we swapping in between? So I know that my current index is I and my desired index is idx, so I have to swap between I and idx. Okay, so let me get the nums idx into the temp variable. So we have copied this variable over here, and what we'll be doing is we'll take whatever is in nums_i and put it in nums idx. So we are done, and nums_i will update with temp. So basically we just performed a normal swapping over here. Okay, and what we are going to do, we are going to continue. We are not going to go ahead anyways in the loop, and if I do not enter, what I'll do is I am just going to increment the I in that case, right? And so at the end of this array, what will happen is we will have our new array. So new, not new array, the same array, the way we desire, like this. Now we need to do, so this entire transformation we have done in order of n, and again we are going to loop through this array once more to identify what is missing. That will also take a order of n. And as you know that order of 2n is equivalent to order of n, because it is linear. We are not nesting any loops over here. So over here what I'm going to do is I've used I, so just go over this array. Simple. I'm just going, and what I know from here, that inside this array every element should adhere to this rule that we have established over here, right? Every element should adhere to these rules that we have created. So for a particular index, so nums j, what should be the value in nums j? Nums j should have the value j plus 1, right? If it is so, that means the element is so. Say 0 at 0th location. What should I have? I should have a 1. So j plus 1 is 0 plus 1, which is 1, and nums j means 0th location should have a value which is 1. If it does not have it, that means that element itself is missing over here. So in that case, what should we return? We should return j plus 1. Why plus 1? Because we are interested in values 1 and above. For 0th index, if we see a different value is sitting there, that means 1 is missing, right? So that is all. And now another happy part that I wanted to mention, that if I have something over here like this, I have a array of 5 elements like this, and we have all the perfect elements over here. We have everything that uh, we need inside this array in order or in different order. Let's say it could be 5 4 1 3 2 or whatever, or 5 4 3 2 1 whatever, but all the required elements are present. So in that case, the first missing number is 6. So in that case, what will happen? This condition will never satisfy and it will never go inside this block. And if it doesn't, that means it will never return anything. So once we are going to exit this loop, we are going to return that. What are we going to return? So this was our interested range, right? Nums dot length. So we are going to send 1 plus 1 and send it back. So what does it mean? So if I have an array of size 5 and I know that all the elements are present there, so nums dot length plus 1 is what we are going to return from here. So we are going to return a nums.length plus 1. So that will return a 6. And 6 will be 6 is our first missing element in this case, right? It should ideally run because it's the same code from my previous example. So yeah, you can see that it has been accepted. Let's do a submit. So yeah, this is the submission that we did earlier as well. So here you can see that we have a pretty good time complexity, like 0 milliseconds, and we haven't created any extra arrays or anything. So it is the same array that's been given to us. We are making sure that we are using the same array in order to come up with the result that we are looking for. And here also we are traversing once the entire array, and here again we are traversing the entire array only once. So our complexity is order time complexity is order of n. We have not used any extra spaces. So basically we have adhered to the follow-up part as well and have taken care of it properly. So I hope you got the solution at least little better compared to the last video. If you have seen the last video, do let me know. Did I improve upon uh, in terms of maybe handwriting, explanation, or what was better than the previous video and what was not better than the previous video? I would like to hear from you guys. And yeah, if you think this solution was helpful, do give it a like and do subscribe if you haven't done so, and you'll be notified for all the videos coming soon. And once again, thank you for watching. Have a great day. See you guys soon again. Bye bye and take care.